Okay, so in the previous tutorial, we developed a strategy using a simple Grasshopper definition and referencing Rhino geometry to create a 3D letter design. In this tutorial, we will explore another approach in modeling a 3D letter in Grasshopper, which uses what I call a subtractive method, so something similar to this. As well, students, you may decide to avoid using the living hinge, but I do urge you to speak to your tutors in class regarding marking criteria, or we may actually discuss it at the end of lecture in week 2. Regardless, the objective of Project 1 is to introduce you to the process of design to production. So being able to create a simple 3D geometry and process it for fabrication, and as well realize a well-resolved physical object is what's critical for Project 1. Okay, so let's start with a blank canvas. Imagine we have a 3D block which we will sculpt and remove chunks out of, so it would result in a 3D letter S. Let's go to Surface, Primitive. Let's use a center box. We'll use the parametric slider, so go to Parameters tab, Input, Number slider. Slider type integers. Let's change this value to maximum 20. Commit. Copy and paste. Copy and paste. Let's give the height a 4. Now we have a parametric block that we can sculpt to create our 3D letter S. From here, we'll create another box. Copy and paste this short definition. Control C, Control V. With the second block, we will define an area that we can subtract from our main box. With the second box, we need to define where this box should be placed, so let's create a reference point that we can control. Let's give it a number slider. Copy and paste. Now we'll attach this reference point to the box. In the viewport, you'd see that with this reference point, we'd be able to adjust where the box would occur. Okay, so let's start adjusting this second box. So we have this main block and a box that would represent the area we will subtract from the main box. So intersect tab, shape, solid difference. We shall define A as the main box, subtracting the second box. Okay, it's not very clear in the viewport, so we'll have to right-click, de-preview the second box and the main box. So far, this is the resulting geometry when we've removed the second box that we can adjust. Like so. We need to create another defined box to remove the lower part of the letter S. So let's copy and paste the entire second block. Control C, Control V. Move it down. Now let's right click onto this and preview the second block. If you select this, we would see where the box would occur. Okay, not far enough. It needs to have a negative value, so let's adjust the values. Right click onto the number slider, right click values, minimum, negative, let's give it a 20. Commit. Let's simply delete that and create another one. Copy and paste, Control C, Control V. Input Y. Okay, so let's start defining where the second box would occur. Excellent. As you can see, it's a simple logical way to create a three-dimensional S. Now we need to subtract this second box from the main block. Hold down Shift. Excellent. Now let's depreview the second box. Right click and depreview. Now we have a parametric three-dimensional S, letter S. Now we have a parametric three-dimensional letter S that we can, using a subtractive method, that we can adjust. Using the simple logic, we're able to create and develop a parametric three-dimensional letter S. Let's do another variation to this simple definition. So what we can do is, with this original block, we can chamfer the corners. So go to Surface tab, Explode. Let's explode this box. Sets, let's define the bottom face, the bottom surface. Okay, item, number slider. We'd like to select the bottom face of this block. Excellent. Go to Curves, Utilities, Fillet Distance. Excellent. 1 point. It's very difficult to see when you have all the geometries being previewed, so let's de-preview some of these components. Right click on this component, the preview, and let's select the fillet. Now we have a parametric surface that is filleted at the corners. Similar to the process in strategy 1, what we need to do is extrude this filleted surface to create a 3D block form. So Surface tab, Freeform, Extrude. Attach it like so. Direction, again, we need vector Z direction to create a height. Okay, great. Now, since this extrusion is originated from our main box or our main block, what I like to do is make a a logical connection with some of the parameters defining this block. So for the height value, which is this z in this block, what we can do is multiply it by 2 to give us the exact same. Right click on the B, set data item 2, commit, and feed it into Z. Excellent. So now this would ensure that we have the same height value for this extrusion as the original block. Is the extrusion, oh sorry, we actually missed a step here. So with a fillet, what we need to do is create an actual surface. So go to Surface tab, Freeform, Boundary Surface. With this curve, we will create an actual 2D shape which we will use to extrude. Okay, great. Now we have a 3D geometry. With this solid difference component, we will need to replace A with the extrusion. Excellent. There we go. Let's de-preview some of these components. Great. Here's a simple definition using a subtractive method to create a three-dimensional letter S. We'll set this aside for now and explore other strategies in creating a three-dimensional letter S. Group, excellent. Let's de-preview this and start with a new canvas for the next tutorial.